All right. So let's take a look at sampling. So I told you all the issue with sampling is that if you have a population, right? If you have a population, right? Population might be too large, right? The population is every element, right? And to deal with a population might be too large. So what we do instead is we do something called a sample, right? A sample, like here I have 4 samples, right? Samples are subsets of population. All right. So sometimes we are to do give these samples. If by chance you go to the entire population, call that a census. So if you do something called a census, I don't know if you all ever heard about the national census. That's every single person in Trinidad, right? So census is done on everyone in population. So if by chance the population is small enough like ours, and you do a full census, right? Or you do a full testing, it's called a census. Right? If on the other hand, you do something called a survey, that's on sample, right? Okay. So let's see the type of sampling techniques that we have, right? So the types of sampling techniques, right? So some of the sampling techniques that we have, the one that we kind of talked about last week, right? The first one we talked about was the simple random sampling, right? Simple random sampling. Sometimes I would just use SRS, right? That's where we just simply randomly choose people. So if I have 10 people and I randomly choose people, that's simple random. One of the ways that we can do it is give each person a number and use like the random number table I showed you last week. Okay. Second one is something called systematic sampling. So I'm going to explain it one time. What is systematic sampling? So systematic sampling is where the first thing we do in systematic sampling, we give each person a number. Very similar to this. So we number, or sometimes we call it listing, each person in a sample frame. Right? So you put each person that you want to sample, we give them a number. Okay? And after we do that, what you want to do is choose every nth person. All right? So I'm going to give you an example, right? Let's say, for example, we had 10 people. Let's say we had 10 people. Person 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's call them A, B, C, D, E, F, G, H, I, J. Let's say we have 10 people, right? And from these 10 people, you want to get a sample of 3. We could use systematic random sampling, right? So to use systematic random sampling, all I have to do is number everybody and then choose the n person. So for example, I might choose every third person, right? So I'll choose C, then I would choose F, then I would choose I, right? So I'll end up with a sample C, F, I. That's okay? So you list them out and then you choose the end, right? How would you know what position is based on the amount of people? Okay? 10 divided by 3, you'll get like 3.33. So you can choose every third person. You can round it down and choose every third person. But okay with that? Anybody can see a problem with something like this?
Bias.
Bias in terms of what?
It comes as the features from one particular person, start, what was your business? See.
So what you say is that just suppose, the first 7 are girls and the next 3 are boys. What you'll end up with? 2 girls, 1 boy. Or suppose a household. Suppose a household, right? And you have 10 people living in the household. And you ideally want to get 1 person per household. What would happen here? This household would have had 3 people in it. Okay? What could be a problem? So you might miss out people, yeah, might end up missing out people. But a very big problem with systematic sampling is that we had to list all the people, right? Suppose some people who live in the house not listed. Like for example, you want to take a phone book, right? In a phone book, every single person in the house not listed there, right? So if you list all the people in a phone book and then use systematic sampling, what could happen? Then people could be left out. Whoever without a phone could be left out. So one of the major problems here is generating that sampling free, right? One of the problems is generating that sampling free. Okay, so make a note of that. One of the disadvantages of systematic sampling is that it's difficult to generate. One of the disadvantages of systematic sampling is that it's difficult to generate the sampling frame. That is to obtain a proper list of everyone in the population. That is to obtain a proper list of everyone in the population. Right? Next one, the one that we use the most. Oh, we got the obvious person. Go on. Right. So the next one, very, very popular. Stratify sampling. It's the most popular one, right? So when do we use stratified sampling? Well, when groups or strata are available, right? We choose by proportion. We choose by proportion from each strata. Right? Any questions there? Online stuff, all right? All right. We choose something and we'll get some better now. Actually, how are you doing? I'll show you. I'm going to put the handle wrong. Okay, so here we have 40 people. In this company, you have 20 laborers, 10 masons, and 10 foremen, right? And you want to be able to get a sample of 10, right? What you're going to do now is choose by proportion, right? Proportion means that based on the number of laborers they have there, that will be the proportion represented in the sample. Okay, so you want everything nice and even. You don't want more foremen than laborers because the sample has more, population has more laborers, right? That's okay. So you want to make sure that it's there by proportion. So here what you do. What you will do here is of the 20 people, right? Remember you want to get a sample of 10 out of how much? 40. So of the 20, it will be 10 over 40. So you will get 5 people. So you're gonna choose 5 for me. Okay with that? Same principle here. 10 by 10 over 40, right? That'll be about 2.5 people here. 10 by 10 over 40, that'll be 2.5. Nice. Problem is we do have 2.5 people. What you do? What you do in a case like that is this. Here, you round off. And you'll get 3. But here, what you'll do, because you have 5 and 3 people, 5 and 3, 8, right? To get the remainder, what you do is 10 minus 8. That'll give you 2. So here you round down. If you round up somewhere, you're going to have to round down somewhere else. Are you okay with that? That's if you get fractions. So the way you deal with decimals or fractions, because you can't have half a 0.5 a person. The way you deal with it, you round off one of them, and then you round down the rest. Sometimes you will get 2.7 and 1.3. So you round off here and you can round off here. That's okay? But if you see something like this, yeah. How come you don't do? Because it's based on the ratio. This is double all of them. Yeah, but because you end up with the problem, yeah, but if you choose 3 and 3 and 4, then your ratio here higher than here. Can't do that. So because you end up with a problem here, you'll have to deal with it here. Right? So think about it. If you have a ratio of 4, 3, 3 here, as opposed to 5, 3, 2, which one is a better representation of this? 5, 3, 2 might be a better representation, right? And that is your objective, to make the sample as close as the population. All right? That's a good question. Mind the way to go. You get started in school, or you know? Yeah. Real Java. I know you have come in person before. Joshua. Ada, no. Name seem familiar. Right, so that's the principle of a stratified sample. You choose by proportion, right? And going to the next two types. Quota and cluster. Right? What's the difference between them?
Hotels, fruits, how much are they?
No, what is no? Not what is quota. What's the difference between quota cluster, those two, and the three?
No.
Right. Basically non-random or non-powerful. Right? We introduce more bias into the next two. So these two here, make a note. Sorry, these three. Right? So these three sampling techniques. These three sampling techniques are said to be random, or probable techniques. Random or probable techniques with less bias. With less bias than the last two techniques. With less bias than the last two techniques. Right, and the last two. The last two are cluster sampling and quota sampling. Right, what you do is you tell me the problem for them, right? I'll give you an example of cluster sampling one time. This is multi-layer sampling, right? So let's say we have Trinidad. right? And Trinidad is broken up into counties, right? I can't remember them, right? Let's just say we have county A, B, C, D, E, F, right? And we want to get schools. We want to sample about, we want to obtain a sample of 5 from 3 classes, right? So here's how we can obtain these 5 classes. What we could do is from these, we could obtain 1, 2, 3, 4, 5. We could probably do 2 counties. Let's say we pick county F and county B, right? Then within the counties, then we have schools, right? So the first layer is to get a county. Second layer, so you might have 20 schools in here, 30 schools in here. Next layer is to get this school, right? And then when you select this school, the next layer is to get the former 3 class, right? So you're doing sampling by clusters. First one, county. Second one, school. Then you pick form 3, right? What could be a problem for that? As you can see here, one of the problems with we end up with everything far, let's call it far north, far south, or far northeast, far southwest. We get no schools in central area, right? We end up with basically rural schools. You see that? So we end up with rural schools, and then from the rural schools, we might end up with non-prestige schools, and then we end up with small countries in terms of class size, right? So we keep introducing some biasness here. When we choose county, we went rural. When we choose schools, we choose small schools, non-prestige. And then here we end up with small classes. So we keep introducing possible errors. So if I choose Form 3, some these schools, I will end up with what? I would end up with schools with no internet, or schools with real small numbers in the classes, right? So I'm not getting a true depiction of what will probably happen here as well, right? If I come to a school like NAPS or something, you'll have like 40 something children in a Form 3, right? So by doing cluster sampling, we're introducing bias at each level. All right? And that's what make it non-random. And what's quota sampling? That's the one that we use all the time, but people use all the time. So imagine it going into the mall and you want to find out from the people in the mall what's your favorite store. What you might do is come in front of the small gate and the first 100 people, you ask them. And you get your quota, right? You all ever saw, for example, those samples on like TV6, and they always say, thanks for making us the best, for the most popular TV station. And what they do, sorry, not TV6, like Express. What they might do is every single person who come in to buy Express, they might sample them. But what that person will say, and they will say that Express is the favorite, right? So it introduces what? Biasness as well. So quota sampling is where you go into a particular area and you obtain whatever quota or whatever amount that you need to get. Okay? Make a note of that. Quota sampling is when little or no randomness is applied. When little or no randomness is applied. When little or no randomness is applied when obtaining the required sampling number. Okay, so these are 2 non-random, all the other 3 are random. Will you give it up? Yeah. So let's see if we can try a couple of questions on sampling, right? Right. So in your project, right, you all need to remember when you have to explain how your data is collected, you have to give a detailed explanation of what sampling techniques you use, right? No. Is that in this class?
Oh, yeah. They have to.
Oh, okay, okay, okay. All right, I'll remove one randomly, right? This one?
Yeah. Yeah, yeah.
All right. Right, that's a few of these, right? One thing I didn't talk to you about was something that you're supposed to know. What's the difference between qualitative and quantitative data? Kelly? Which one is qualitative? One is numbers and one is words.
Oh.
Right? Qualitative is quality. Quality is words and quantity is numbers. Right? Because I forgot to talk about that, right? Right? Quantitative is numbers like age and height and things. And the qualitative is words. Or letter. No. Right? Actually blocking graphic, but just like one or two cumulative frequency and thing, right? Or we can leave it out, it's up to one.
Yeah, we do it.
But I want to make sure we do like one, so you remember those things, right?
In the.
Right, let's start here. 2017.
Yes.
To match the phrases or statements, so just write 2017 number A and just put the letter here, right? By writing the number from column A in the appropriate piece. Right? An example of quantitative data is which one? 1, 2, 3, 4, 5. 3, right? Yeah. So do write everything, right? All I want you to do is just write C and write a number for C. When you're ready again. Okay, do the first one, right? So data which can be counted. What is that? That's this discrete data. A simple random sample is what? Sorry, it's systematic. I want to know. Yeah, a systematic random sample. Which one? Number 5, right? Choose the end. A method of collecting data from a sample survey, right? A part of population. One. That's okay? If you want, you can use it as definitions as well, right? Discrete data like whole numbers, like 4, 5, 9. Right? Continuous data is like if you have height and you have a range of values, 11.4, 11.3 as consequence. 3 and 4 will be the same. No, but quantitative data could, or I mean, discrete data could also be like groups. Right? That's discrete. You only have one option. If we do all three of them, male, well, should be like some. That's just free data as well. Right? Let's go again. Sorry, I did pretty good. What's up? Huh? C and D plus push-ups. Yes, I will share all these papers so you have. Huh? You know, if you was Phil can choose them, so you sort out Phil. Phil sort out Phil. Phil easy. Then let's focus on this. Determine whether each of the following refers to a sample or to a population. A group of 25 selected to test a new drug. That's a sample, right? Total number of books on sale. Right, that will be population. Next one. Keyword is total and selected. Right? The couple words, right? Which is discrete, which is continuous. Make a note of them if you're not sure which word is which is which, right? And make a little note of it. Huh? Yeah. All right. Right, first one, number of persons in a household. Discrete or continuous? Discrete, nice. Speed of a car. Continuous, but it could be like point something, right? Or some people just give like whole numbers alone. But when you speed of a car is some continuous, especially in 29. Student enrollment. Nice. Let's go again. Okay. Yeah. Try this stratify here. You're showing your email. Check in spam or something. Because your name on the group. Your name there. Right on. The spam.
So share your email.
Readiness.
Give them as well. The original someone.
On the element, that's that much email. Oh, yeah. Hello? Right, so if you not send back the email and let them check it, right? And then you add your one time, right? So the following table shows the type and number of workers employed by a garment factory. A sample of 15 workers must be selected to attend a conference. So it's 15 people we need, right? 15 from 60. Using a stratified random sampling, calculate the number of workers for each of the group there. So basically here would be multiplied by 15 on 60 is a quarter, right? Right? So you multiply by a quarter, multiply by a quarter, multiply by a quarter. Why didn't you give us a better number? Right? So this one here is 5, all the others kind of lame, right? 10 is what? 2.5. We round it up just now, just to make sure. 5 is what? 5 is 1.25, right? That make it kind of easy. 25 is what? 6.25. Right? So let's just see how it works out. This might be 3. This will be 5. This will be 1. Right? And what the last one will be. Right? So it worked out okay. All right? And that's a fair enough representation of the sample. 5 comes from the largest, 10, 25 provides 6, 10 provides 3. So I don't even want to kind of work. 10 could have been 2. Anyway, but that's what we got. 3, 5, 1, 6. Everybody okay with that? Right? So that is your sample. Let's see if we can squeeze in one more now. We do this one fast. Ready? Yeah. Good one. Ready? Online, any questions? Sebastian, pay attention. Nathan, you good? So that was 2017. Let's try. That was 17 or 19. 17, let's try 19. Huh?
That's all right. It's in the first.
Is that right? Now, yeah.
Possible.
Was that with email?
Yeah. I was starting in the last special.
Just use one for the four of them.
Actually, first.
Let's try 19. Nineteen in the group. Take us in 19 in the group, so you can work at your pace, right? Yeah. Nope. Anybody have 19 close to them? Okay, that's it. Right, so do 2019 number one. Right, ascending group as well. 2019 number one. That right? 2019 number one, right?
Sì, diciamo, ma poi che ti danno quanti spesa un po' di questo. Ciao.
But tell them, yeah, so what's the word? But you gotta figure out the word that best describe. And then you will help us to. right? It's fairly simple. I'm giving number 10, right? AB, you can do the whole thing, go on number one. Then you go. The last one I sent, 2019.
Thanks, John.
Yeah, can you find that one down? A little sketch, a little sketch. Okay. All right, I'll do the whole thing. Ready? No, either way, you start.
Full thing.
Right, so you have A, B, I can start with A and B. I can start A and B earlier.
Yes.
So the first one. Right. First one is the marks obtained by the students of the 2015 statistics class in an examination. What's that? Population of statistics population. A group of 15 persons at a conference selected to sit in a committee. The number of tests that occurred in a certain district in the last week. The number of tests that occurred in a certain district. So the number of all right. So that will be population. Right, the selection wasn't really made on these. They didn't specify anything about selecting the district. They just said all the cars in a district. All right. The total number of cakes produced during the last week. Population. All right. Any questions there online? Next one. Give 3 reasons why the use of a sample may be necessary. Right. State 3 reasons why the use of a sample may be necessary when collecting statistical data. Always take that time, money, and cheaper, less time, and okay, represent the population. What else? Right, less data, so the computations are a little bit simpler. Right? Anything else?
Requires a smaller sample.
No, you still need the same sample. Sample frame all. Right? That the frame is sampled from. Okay, anything else? Right, so always think first 2 things come to your mind is time and money. Shorter, less money. Right? And I need to any idea of that. C. State the word will best define each and the following. A numerical measure calculated for I can give it this one. A numerical measure calculated for the population data. So you have 2 words that we have to learn about. parameters. And for the next one, I'll split it in here. So sorry about that. I didn't give it. Parameters and statistics. Right? Parameters come from populations. Statistics come from samples. Okay? Sorry about that. So a numerical measure calculated from population data, write down that definition. That'll be the definition for parameters. Statistics is a numerical measure calculated from sample data. Right? In the small PDF that I sent you on my thing, you'll see it, right? Right? So parameters is a numerical measure calculated for the population data. Statistics is a numerical measure calculated for sample data. For sample data. Next one. The questionnaire completed by all the students who attended the Higher Heights Academy. Survey. No, not sample survey. That will be the consensus. Sorry, yes. Spelling right? Yeah, anyway, consensus. Spell that right? I spell that again? Sorry. PNSUS, right? Okay. Sorry, I'm not going. Yes, census. Consensus is that?
Yes.
More like a right? But no. No, that's all the students who attended. Right? Census is the all, right? So that's why it's not a sample survey, all everybody. How about? You're almost done. Are you okay with that? Identify which of the following variables are quantitative, qualitative. Further classify each of the quantitative as discrete or continuous.
Quantitative.
Right? Marital status is what? Qualitative, right? Weight of babies.
Quantitative.
And continuous. Occupants of the persons who cruised on Carnival Lines last year. Qualitative, right? They didn't ask us to separate us. Number of cars that were written off. Quantitative and discrete. Nice. Quantitative and discrete. Very good. I'll do this calculation fast. You're done?
Yeah.
Calculation?
Yeah.
Okay. You're done? Oh yeah, do the calculation. Forget the pie chart. Oh yeah, just because see me done. So I will pie chart. Right? Next week we'll go over the form 5 stuff. Right? Mean, median, mode, and that kind of thing. So we can run to module 1. Right? Just because ignore the calculus, ignore the pie chart. You don't even want to marathon, paper. Don't have like a school marathon, paper. Have to pay that, right? Yeah. And but you pay a smaller amount than people outside, you pay a lot more. Right, need a sample of 50. According to proportion, we have 600 students. 96 are, sorry, 96 are registered in commerce. Using the sampling technique, calculate the number of commerce. So commerce will be 96. Right, and the sample we need to get 50 out of 600. How much you get it? 8 people. So give it up. Yeah, so very easy, right? Like technically number 1, 2, and 3 in this module really. Right? 4 is a little more work to remember, but module 1 and 2 will take you, and the exam might take you half an hour to 45 minutes. Right? And then you have the rest of the time module 3.
How long will it take?
1.5, eh? No, 2.5 hours. People just finish an hour and a half. That's why I got that. People just finish the 2 hour, 2.5 hour paper an hour. It's one of the easy exams to do. I'll show you. I do something. That would need that. That's